Hey there, welcome back to the vlog. So today is going to be a technical one. If you're not into the technical programming vlogs, then please come back tomorrow. Okay, so as those who have been following the blog will know, we've been building the same application using different methods, and today we're going to do it the old-fashioned Win32 way. Now, we already did an iPhone version and we did an Android version. The reason that I'm doing number 3 as the Win32 version is because if you understand this one, it will give you some idea as to what the modern frameworks are doing later when we do more on Windows. So the first thing I'm going to do is fire up Visual Studio. Once Visual Studio is fired up, we're going to create a new project. We're going to pick C++. We're going to go to General and we want an empty project. So I'm going to give it a name. Win32 test app, and we're going to click OK. So what this is going to give us is a very bare bones Windows application. Okay, so what it's done is it's created a project, but there's nothing in it. There's no source files, there's no resources, there's no header files, there's literally zero in there. What we're going to do is we're going to create a source file. So I'm going to go add new item, and it's going to be a C++ file, and I'm just going to call this main.cpp. So once it's created, we have a basic blank window. What I'm going to do now is pre-populate it with a little bit of code, because it would be a very long video if we were to do this, literally me typing out. So I'm going to paste some in, and then we're going to go over it. So the first bit of code that we have, it's not very long, but I'll just quickly go over it. We have some includes, and that just basically allows us to import some functionality that is pre-written elsewhere. The windows.h has all of the definitions for the Windows operating system, and then we have string here, and string just allows us to do some basic string manipulation when we come to taking text out of the text box and putting it into a static. So we also have here what's called the windproc, or the window procedure. Now the idea under Windows is that it's an event-driven language, and in order for those events to trigger something, you basically have a loop called the message pump. So the way this works is if I click a button, the system will send a message and put it into like a mailbox that then later the application will go and check. It runs through a big if statement, and that if statement or switch statement will then go, okay, if it was this button that was clicked, do this. If it was that button that was clicked, do something else. So that's where the windproc sits in here. So I also have a couple of handles set up just to store some basic information. Now you may have noticed, for instance, if we go into the task manager, one of the pieces of information that it used to give you, I don't know if it still does, let me have a look under, yeah. So down here we have handles. Now the way this works is rather than have an explicit grasp on objects being created, handles, they come from a pool and they go back to a pool. And Windows has a certain number of these tags, for want of a better description, that it can attach to stuff. So I don't know what the exact number of my window is, or the exact instance of my application is. Windows will keep track of that, but we store it in these handles, which later will get reclaimed by the operating system. So I have here some basic handles set up. One is for my window, and the other one is for the instance of the application. I'll show you in a minute where those get created, but we just basically use them to make sure that anything we're dealing with is for our app and not for some other app. And also by keeping a track of what the main window number was, or the handle of that main window, that also means that we can eradicate any sort of messages that weren't actually for us, because it could be for other windows within our application. We're only interested in our main window. I then have window handles for the input, the button, and the output. And if you've seen how we did the application under iOS and how we did it under Android, the most simple application that we created was you type in some text in a text box, you press the button, and the label then displays that same text. The reason it was done very simple was because when I came to do this particular version of that application, this is going to be nearly 90 lines of code, which is a lot of code to sit there and have to do manually, and I just didn't want to do that otherwise. So yeah, that's why we did it that way. I then have a couple of identifiers One for the text box, one for the button, one for the label. And labels under Windows, they're called statics. And I guess it's because they're static text that you can't change. We can still change it programmatically, but the end user can't change it. In normal applications, they normally start with what's called the main function. In Windows, it starts with WinMain. That's the starting point. And what will happen is the application is started, it is passed an instance, any previous instance of the application, and this is normally used for, let's say for instance, you have one application but only one copy can run. It can check to see if there was a previous instance of the application running, as well as any other information telling us how to show the window, whether it's maximized, minimized, or whatever. So that information gets passed in. We have a couple of declarations here that are set up. One's for messages and one's for the window class. Now, I'm going to quickly show you something here. So if I run up Spy, yep. So a window is a rectangular object that has a parent, and it normally has some text, and it has an XY coordinate, and sometimes it has a Z order. It also has a width and a height. That's pretty much a window. Now, everything else is also a window. So buttons are windows, text boxes are windows, the windows they sit on are windows, the desktop that those windows are attached to, that's also a window. When they called the operating system Windows, it was not just to tell you that your apps run in Windows, it's actually made up of windows. There are windows on top of windows on top of windows. And we can actually look at this. Like if I use this spy tool, I can drag this thing over and I can see here, as I mouse over the Visual Studio in the background, we can see what it came up with. Here's the text. This text here matches what's up at the top of the window. We can also see a class, and it tells us what the class is, and in this case it's a wrapper window, and we'll be using these classes in a minute. Now if I pick a different app, let's say for instance I load up something else, so let's pick the antivirus on here. So the antivirus window, when I mouse over it, we can see that this is actually, it's Internet Explorer server, so it's a web page running within a frame. So you wouldn't know that looking at this, but that's what's going on there. So if I hit close, now let's see what that's made up of. I'm just going to move this to make it a little bit smaller and put it out the way, and then just reload up that bit again. Right, okay, so we've got an Internet Explorer server, and that's pretty much everything on that window. Okay, that one's not an exciting one. Let me try one of the older apps. Right, so as you can see here, when I move over each of the different views, it changes what the class list is. So here we can see we've got system list 32. So the syslist view 32, that is a standard list view that can also change from being rows like this to the grid. Does this one have a ability to show by grid? Yeah, it's got a different one. But this was something that was introduced with Windows 95. So that's one of the new controls in Windows 95, and here we are, 20 odd years later, it's still there. We can then see, for instance, here is a toolbar Window 32. We can see there's another toolbar Window 32. The items within this, no, I can't drill down into them. Oh, I can drill down into this one. So here's a sys header 32, and then yep, we've got here so Microsoft controls status bar 32. That was the standard status bar. Okay, we can actually tell from this now what this was built with. This was built using MFC because we've got an AFX window 42. So as you can see, we've got different window classes and then captions of windows, and each window has a handle, which is this item here. So as I move around, you can see the handle changes, and this handle becomes very, very important because when I'm addressing a window, I can send messages, and it's the handle is the effective recipient address. So if I come back again, so we've got a window class, so we're setting up a pointer to a function called the winproc, which will be put in place in a minute. We have the instance of the window is going to be whatever Windows told us our instance was. We have a handle to the background brush, So I can set a background color if I want for the window. We then have the class name. Now here I've got the super duper Windows app is the class name, and we then register that class with Windows. So what that does is it says like, okay, Windows, we're going to start creating windows in a minute, and we're going to create a type, and it's called the super duper Windows app type, and give us the information to actually register this. So on the next line, we call create window, and we pass in all of that information along with the title, which is our wonderful Windows application. We specify how it's going to look, whether it's got borders, no borders, what the size of it is, items like that. And that returns the handle to the window that it just created. What will then happen is we'll store the instance up here as well. So we've got our handle to our window and our instance, and we store that out of the way so that we can come back to it later. So as you can see here, once we get down to this point, we have a loop where it's going round and round and round. And what it's doing is it gets the message from the message queue. It translates that message to generate any key codes that need to be done, key presses, things like that. And then it does a dispatch message. And basically what at this point happens is it drops back into this function called the WinProc, where we can process it. And then after we're done with it, we pass it to what's called a default WinProc. And that default WinProc is what Windows is doing with it. And they handle any messages that we don't handle, and then things get nicely cleaned up. So the next thing we have to do is actually go and put in this WinProc, because right now, as you can see, there's nothing down there. So now I've put in the window procedure. As you can see, it sends back a result. It's a callback, which we know because it gets called by this here. Sorry, by this here. It has 4 parameters. So there's a window handle, which is basically the recipient. We have the message, telling us what the event is that happened, and then we have 2 parameters. We have the W param and L param. Normally we use mostly the L param, but sometimes for identification purposes we will use the W param, and I'll show you that in a minute. So what I'm now going to do is start building this out, and you'll suddenly have this realization of how this works. So the first thing we're going to do is we're going to add a switch on the message, and that allows us to basically say any message type that we want to know about, we can pull it out and handle it. So what I've done here is I've added a switch on the message which allows us to filter out the messages we do want, and then what will happen is if anything is unhandled, or once we're finished with any particular message, it will go down into this default Windows procedure where the same message untouched generally goes in there. Now when I say untouched, we can change things around. You can basically mug the mailman, change the message, and then pass on your changed message into here. Whilst that works for certain tricks that you might want to do, it's generally not something that you do very often with any valid reason other than just messing around. So what we're now going to do is add the case statements to the switch part here, allowing us to start building this out. Now if I go to the Windows API, so let me just Windows API. Microsoft has a huge amount of documentation online, and what you'll notice is it's all broken into areas. So for instance, we've got the user interface, we then have the shell, input and messaging. So we're going to spend most of our time in the user interface part, specifically dealing with the common controls here. So the buttons, the edit controls, and do we have a static? Yes, statics down here. So what I'm going to do is just add one last little bit, because without handling at least the close message, once we create our window, we can't actually close it. So what will happen is our window will get the message WM close, and WM close, when we receive that, we will call post quit message, which will basically tell Windows, hey look, we're done, close this down, and at that point we'll drop out, run the default WinProc, we will return 0, and we're out. Okay, so we're going to run this up. So here we can see our wonderful Windows application, and if I click the close button, it does actually close out. We can actually put a breakpoint in here. If I run this again and now click on here, you can see we've just hit the breakpoint. So the message that came in, we had a window handle. We can see here's the handle. We can see the message 16, there's 0 on the W param and there's 0 on the L param. I mean, it's pretty straightforward. This is just okay, we're closing down. If you want to check with the user, are they sure they want to do it? Now's the time to do that. We're just going to let it go, post quit message, and be done with this. What we'll now do is we'll add some extra functionality to this, because obviously we want a user interface to be created here. And what we're going to do is we're going to look for the WM create message. So if I put here case WM, whoops, can't spell, WM create, that's the message we're looking for. That gets posted to our window when it's first being created. And just in case you're wondering what WM stands for, it stands for Windows message. So when the Windows message create, which is message number 1, when that comes through, we will then go, right, now we have a window, we've been created, we're going to quickly draw our user interface on that window. So I've just quickly pasted in this code, and what you'll notice is we quickly grab the window handle that's coming in and store that. That gets stored just up here, just in case I ever want it. I ended up not using it on this particular example, but yeah, that's where I would do it if I normally would store in this. So after that, we grab the handle to the text box that we called text input, and you'll notice here we're calling create window. We're saying it's an edit. That's the class of the window. It's not a super duper Windows app. This is now an edit window, which means it's a text box. That's our text that we're going to put in the text box. We have here, it's a child window. The style, it's going to be left styled. It's visible, and it starts at X50, Y50. It's 380 wide, and it's 25 deep. Then its parent is the main window. And we also give it an ID. So the reason we have an ID here is so that we can identify the child window within the big window. Then this is tied to our main instance, and this last parameter, we don't need to worry about it. So it's exactly the same as what we were doing up here, but as I said, instead of using this custom class for our own window, we're using now a static, we're now using a pre-registered window class called an edit for the text box, button for the button, static for the label. And as you can see, they all take pretty much the same parameters. So once we come down, actually, let's rerun this right now. So now, when that WM create message came through, the first thing we did was we quickly banged out these 3 controls and put them onto the user interface. Now I can type here, that will work, but if I press the button, nothing's going to happen. What's actually happening is when I press this button, there is a message, a WM command message that's dropping through here, but we don't have a case WM command anywhere, so we're not catching it. So that's what we're going to fix next. Okay, so now I've added a WM command to here, and what I'm doing is I'm unpacking the W param that's coming in here and looking at the low word of that to find out if the identifier for the thing that's being clicked is the IDC button, which is what we set up here. And when we registered the button, we said, look, give it this ID. So there are some API calls. In this case, we've got set window text and get window text, which are here and here. And what we're basically doing is, if we determine that something has been clicked and that something happens to be our button, then create a string, do get window text, send that message to the text input, send across the string and the length of the string. It's filling that string in, and then what we're then doing is we're getting the dialog item from the H main window. The item is the static, and then that particular item, once we return it, we're calling this set window text and passing in the text that we built up here. So now if I run this, so if I type in hello and press me, now you can see that that's gone straight through. Now, I mean, it's a very long-handed way of doing stuff. If I change the size of the form, none of this moves because I'm not even handling the WM resize event. And there's so much that you can do manually. We're not handling any of it, but I mean, you could do a lot of stuff here that I mean, there is just so much to do here. And just to quickly go back to this spy tool, because now this will make some sense. We've got, if I go over our window, we can see here, the caption is our wonderful Windows application, which is what's written up here. We can see the class is the super duper Windows app. And if I go over here, we can see that's the edit, that is the button, and that is the static. And that is how you create a basic Windows app. Once you understand that this is how the Windows apps are working and how that message pump is working, we will now be able to do the other examples where we'll start using .NET and VB and things like this, C#, and you will have an understanding of what they tried to simplify. Up until Visual Basic for Windows came out, if you were a Windows developer, you had to do it this way. Like, there was no other way of doing it. Even Microsoft, they tried to come up with a new way to try and simplify things, and it was called the the MFC, which was the Microsoft Foundation classes. And the idea was that they had ways of trying to automate some of this stuff in I guess the things that were common, opening windows, handling files, streams, buttons, toolbars, stuff like that. And the problem with that is it still generated these really, really massive apps that were horribly complicated. They buried some of the gnarly parts of the Windows pump, but then they set up these message maps that still just basically reintroduced gnarly parts of the message pump. So things took a long, long time to go forward to the point where it was easier on the developer. And just to quickly really ram home this stuff, like if I move this down to here, I mean, you can see here we've got the task list down there, we've got toolbar windows, tray clocks. Like, things haven't changed. As the rendering engines may have changed, the actual underlying what's being shown in the operating system, that has not changed. Like, stuff is still the same as it always used to be. Is this still a button? Whoops. Is there still a button down here? Yep, that's still a button. Yeah, I can still see that's a tree grid there. Yeah, like, I mean, it's things really haven't changed at all. So anyway, hopefully that now gives you some idea of how Windows works, and using this information, you will have some appreciation for what's really going on under the hood, and also why things can fail. Like, when you have an app that locks up, the chances are there's something in the message pump that it's waiting to have completed that has not completed, and therefore the entire application stops. And when you start mashing the keyboard and moving the mouse, all you're doing is you're just posting more messages into the queue, so that at some point when the message pump does start picking up messages again, now it's got even more work to do, because like that was what you were doing. You were posting more messages. Every time you do something, you generate an event, and that's how Windows works. So anyway, hope you found that one interesting. As I said, it's a very complicated subject, and we could literally spend days and days down in here going over the finer points of this, but I'm really trying to keep this at the very, very high level. If you did miss the previous installments of this series, I'll put the link up in the doobly-doo right now. And that's it for this particular vlog. So, if you like these, give it a thumbs up. If you don't like it, thumbs down. If you want to see more, please hit subscribe, and speak to you soon. Alright, thanks very much. Bye.